Hello everyone, my name is Manuel Chenga. Welcome back to my YouTube channel. If you haven't subscribed, make sure you subscribe. This is the channel where we'll be discussing about this different subject that you find in engineering. So if you have checked my previous video, I was talking about the subject engineering side, whereby we're talking about the topic called dynamics. So this is a continuation from where I left yesterday. So if you haven't watched the video, make sure you go and watch the video. That's why we talk about the basics of the what is a scalar and also the definition of what is a vector. So if you check my previous video, we're talking about how you can do the calculation whereby you are given vectors which are on a straight line or vectors which are opposing the direction. So basically today is just a continuation of dynamics, and then today I want to deal with the addition of vectors in a different direction. So this is whereby you are given a certain vectors, but your vectors that are no longer in a straight line, they are now given in a different direction. So basically I'm going to show you on how you can calculate or how you can get your resulting when you are given vectors which are on a different direction. So let's start with my number one. Here I've put 3 examples which are on this board, whereby we are going to use that as examples. So the first one is saying add 2 Newton north and 2 Newton east to get your resultant. So if you can see from my number one, I'm given 2 vectors, or I'm given 2 forces which are acting on a different direction. Let me firstly just draw on the board. So you are given a force which is going up, which is 2 Newtons, which is going to the north, and then they're saying plus 2 Newtons going to the east. You are also given another force which is 2 Newton going to the east direction. So basically the first thing that you need whenever you are given forces which are now acting on a different direction, the first thing that you need is a scale. Because you have to draw. The only way to obtain a resultant when you are given forces which are only acting on a different point is to draw. And how can you draw? You need a scale. And please note you can use a different scale. You can use your own scale that you want. For example, here I can use 1 Newton is equals to 1 centimeter. And forgive me, I don't have the right equipment to demonstrate this, but I'll just give you tips on how you can do that. And if you are having a ruler, you can just work around with your ruler and obtain your answers. Alright, okay, so let's see. So we are saying whenever you are given 2 Newton going to the north and then you are given 2 Newton going to the east. So what you are going to do in your book, you can just grab your book, you can grab your ruler, and then you can draw with me. So the first thing that you need to say 1 Newton is equal to 1 centimeter. So I will need to draw my line, which is equivalent to 2 centimeters going up. And then you can draw another line which is going this side, which is going to be 2 centimeters going to your east. So now you're having 2 lines, and how can you get your resultant? Your resultant need to be from this point to this point. So what you can do, you can just grab your ruler and then you measure this line. So I'm saying the first thing that you need is a scale. You will have your scale, you draw your line which is going to the north, which is 2 centimeters, you draw your line which is going to the east, which is 2 centimeters, and then your resultant, I think if you measure here, you're going to get 2,8 centimeters. And remember, we said 1 Newton is equal to 1 centimeter, so this will be equal to 2,8 Newtons. And please note, if I only write 2,8, this is now a scalar, so it will need the direction. So hence, you have to measure this angle. So let me see what did they get from the textbook. Let me see, they get 45. So if you measure this angle, you are going to have 45, so it will be 2,8 Newton north, 45 degrees of east. So you have your answer. So normally this is how you deal when you are given 2 vectors which are on a different direction. The first thing that you need is the scale, and then you use your own scale that you want, and then you draw, you obtain your answer. So this was my first example. We can try number 2. Okay, so on number 2 they're saying calculate the resultant velocity if the plane flies north 20 degrees of east at 160 kilometers per hour while the wind blows at 40 kilometers per per hour in direction of west, 65 degrees of what? Of north. So mostly guys, you must understand about the compass. This is the north, this is the south, this is the west, this is the east. Know about your compass points in order for you to draw. Okay, so here basically firstly I'm giving the same calculate the result. They want me to calculate the resultant. They say if the plane flies, so you are given the direction of a plane which is flying 20 degrees of northeast. So I measure my 20 degrees here. I have a plane which is flying this side, and then it's flying at 20 kilometers per hour. Okay, the angle is 20 degrees. Okay, this is my plane, and then they are saying now if you have the wind blows at 40 kilometers per hour in the west, going this side of north. Okay, let me just do that, and then times 40 kilometers per hour. Okay, so here you are given two things. You are given a plane which is flying in a certain direction. So when your plane is flying on a certain direction, there is a wind which is opposing the direction of your plane. So your plane is going to end up shifting its direction because of the wind. So that's what they want you to calculate the resultant. So this is a different example from what we did on the first one. The first one they were formulating a right angle or a 90 degree. So how do you deal with this one when you are given two of these forces? Okay, so I said the first thing before you draw, you need a scale. So you need a scale. So here I can use a different scale. I can use 1 millimeter is equals to 2 kilometers per hour. The reason why I'm using a smaller scale because I'm given bigger values, which is 160 kilometers per hour. Alright, okay. So the first thing that you need here, you have 160. So I can divide by 160 by 2, and then it will give me 80 millimeters. So the first thing that you need to draw here, remember I said I don't have my equipment, so I'll just show you how you can achieve this using your ruler. Okay, so I draw my T-junction face. So the first thing I have to draw a line going that side, which is 80 millimeters, and then you have to measure your 20 degrees. And then remember they say north 20 degrees, so you start from the inner side, going this side, you measure, you can use your compass, you measure your 20 degrees, and then your line straight, which is going to be 80 millimeters. And remember we say a plane is going to be forced to come this side. So where your line is ending, that's where you join your 40 kilometers per hour. And then remember the 40 kilometers per hour, they say the angle is what? It's 65 degrees. So what you do, you draw your T-junction here, and then you measure 65 degrees going this side, and then you measure your line of 40. In this case it will be 40 millimeters. When you have these two lines, you see that it's formulating an angle here, so you're resulting it to be from this point to this point. And then after you have to measure this line. Let us see what they obtain from that line. They got 96 millimeters. So you measure the two lines, and then your resultant, you're going to get it from here. And remember, I divide my value by 2, so here I'll multiply my value by 2, and then I'm going to have 192 kilometers per hour. And then the direction is going to be north, and then you measure this angle. This is where you're going to get your answer, and then that angle is going to be north 11 degrees to the east. So basically that's how you deal with if you are also given this type of an example whereby you have two forces opposing each other on a different direction. So that's how you deal with number 2. Okay, let us do the last one. Let us do the last one. So the last one is a bit far. I don't know if you can see, but the same